Okay, section 4.4, we're looking at the area of a triangle. This is an extension of the lesson 4.3, area of a parallelogram, because you're going to find the area in a fairly similar way. A parallelogram is actually just two triangles put together, if you think about it. Therefore, if you think about it, half of a parallelogram is a triangle. And I can show you now. If you take a look, both of these triangles are both 4 centimeters high and 4 centimeters at the base. And then if you take one of the triangles and turn it, it can be put together with the other triangle to make a square. And a square, as we learned last time, is a parallelogram. A base of 4 and a height of 4 would be able to find an area of 16, just like we learned last time. So let's take a look at a parallelogram. So this parallelogram is just two triangles that have been stuck together. So from our last lesson, 4.3, in order to find the area of this, we would take our equation of area is equal to base times height. We could count across our base, and we have to go up our height. Remember, this is not the height. This line here is not the height. That is the length of the sides. This line here would be your height, because it has to be at a 90-degree angle connecting the two parallel lines. So if we were to count that section, we would find that the base is 8, and in this case the height is 8. So to find the area of this parallelogram, we would multiply them together, and we would find that if you were to count every square and half square on the inside, you would come up with 64 centimeters squared. Now, to look at it in a different fashion, if both of these triangles are a half of that parallelogram, how could we find the area of one of these triangles? Well, let's say that we don't have grid paper and we can't count how many squares are on the inside. If we've already decided that a triangle is half of a parallelogram, we could divide our area by 2, and we should be able to find the area of both triangles. So let's take a look. Here we have a triangle. It's much in the idea, the height and the base work together much like a parallelogram does. In this case, the height is outside of the shape so that it can meet on a 90-degree angle from the top tip down to the bottom. The height from the tip to the bottom is 7.2 centimeters, and the base is 9.4 centimeters. This 3 centimeter piece here on the side is only there to help explain the distance between the edge of your shape where it meets the height of your shape. Because this is half of a parallelogram, we're still going to use the beginning part of our original equation. Area equals base times height, but because a triangle is half of a parallelogram, we are going to divide that by 2. So to find the area of a triangle, we multiply the base, which in this case is 9.4, by the height, which is 7.2. So we come across, we replace what we know. We know that the base is 9.4. We know that the height is 7.2. And we know that because it's a triangle and half of a parallelogram, we are going to have to divide it by 2. We do the first part of our equation. We start to do the math, and when we go 9.4 times 7.2, we get 67 and 68 hundredths. But we're not finished yet because we still haven't finished bedmass and divided by 2. So we are going to divide that by 2, and we get 33 and 84 hundredths centimeters squared. Always have to put that little square on the end there. Okay, so area is equal to base times height divided by 2. We multiply our base by our height. It gave us 67 and 68 hundredths. We divide that answer by 2, and we get 33 and 84 hundredths centimeters squared is the area of the yellow section of the triangle. Now, for practice, here's a triangle. You have a base and you have a height. using the formula that we came up with here of area equals base times height, divide that answer by 2. I would like you to find the area of the purple triangle. Bring your answer to class, and we'll check it together.